Well, now we get the pleasure of graphing piecewise defined functions, piecewise functions. And before we go to the calculator and go through the mechanics of graphing a piecewise function, let's look at exactly what we have. Now, we've got two piecewise functions here, but within them are several parent functions, which is part of what makes this pretty interesting. So our first piecewise defined function, we got x minus 5 if x is greater than or equal to, less than or equal to 0. And this x minus 5, when I just look at this portion right here, well, that is a linear function, and it's got a transformation with it. And that transformation would be a vertical shift or translation, vertical shift down by 5 units. Our second part of this piecewise function, x cubed, if x is greater than 0, but less than or equal to 2, well, our x cubed here is just a parent cubic function. All right, so that's interesting. And then the third piece here, we got 2 over x if x is greater than 2. And here we have a reciprocal function, and it's going to have a dilation. It's going to be expanded vertically because this is the same as 2 times 1 over x. And so this is greater than 1, and so this should expand that. We should see a dilation vertically, expanding it vertically. So we got a linear function, we got a cubic function, we got a reciprocal function, and here we got a vertical translation. We got a parent function, and then we've got a dilation. Now let's look at this h of x again before we head to the calculator. Well, I've got in parentheses x plus 6 squared. Well, the x plus 6 squared, that is going to be a quadratic function, another parent function, with a horizontal translation of 6 units to the left, that plus 6. And then I didn't finish that off. X plus 6 squared if x is less than negative 5. Then the second part of this piecewise function of h of x is we got 7. Well, that's just going to be a constant function, a horizontal line. And the conditions are if x is greater than or equal to negative 5 and less than or equal to 2. And then finally, we've got the absolute value of 4 minus x. Okay, so we've got a absolute value parent function. We're going to have a horizontal transformation and a dilation if x is greater than 2. Well, let's move to the calculator and let's go through the mechanics of graphing these functions on a TI-84 calculator. All right, we're over here on the calculator and we're going to graph these piecewise functions. Let me clear out what I had in here before. And let's start by graphing the first piece where it was g of x is x minus 5. And then we're going to put in our condition. And I'm going to start here by putting in a division symbol. And then in parentheses, we're going to put x is less than or equal to 0. So I hit x. Now to get the less than or equal to, I'm going to hit second math, which is the test. And let's see, it's a less than or equal to. So I'm going to choose option 6. And we're going to hit 0 and close our parentheses. That was the first part of our piecewise function. Let's graph the second part, which is x cubed, x caret 3. And again, I'm going to hit the division symbol. And be careful to put into parentheses. Now this I've got an and statement. So we're going to start off with, let's see, 0 test, second math, is less than x, choose option 5, x, and I got to put in the second part of this, and I have to use the logic section. So again, I'm going to hit second math test, but this time I'm going over here to logic, and I'm going to hit and we're going to have x is less than or equal to 2. X, second math, choose option 6, 2, and close our parentheses. And there we've put in the and statement. And now let's go to y3 and finish this off. So we've got 2 over x, that reciprocal function with that dilation. And again, I'm going to hit the division bar. And in parentheses, we're going to say x is greater than 2. So x, second math, choosing option 3, greater than 2, and close the parentheses. And let's take a look at what kind of graphs we got. So we should have one graph coming in blue, one in red, and one in black. And there we go. Oh, let me change the window settings. Because I got it set at, was it -10, 10, and y minimum of -10, and y max of 10. We'll be able to see it a little bit better. It won't be so scrunched up. Now let's go back. And there we are. Now, one thing our graphing calculator doesn't do for us is open dots and closed dots. So on this first, right here, where we're getting that x at 0, we're hitting this vertical axis, that's going to be an open dot. No, that's a closed dot, less than or equal to. That's a closed dot. Then here at the origin, we would have an open dot, and you see it doesn't quite reach there. And we'd have a closed dot up here at 2, because x would be less than or equal to 2 on the second piece of this piecewise function. And then finally, we'd have an open dot here. And let's just go peek at our graph, our table. I'll go in here to the table. All right, and I can see after x is 0 on the first piece, we got an error. In other words, it stops. I've got that arrow would represent an open dot on y2. Would continue on through 2, would give me a closed dot, and then y3, I would have an arrow at 2, where x is 2, and then we'd take off out to infinity. All right, so while we're here, let's go in here, and we're going to just hopefully fairly quickly graph the second function, h of x, which also had 3 pieces associated with it. So, okay, where is it? All right, so first I've got in parentheses, don't want to do that. Let me clear. Go back up to x1. All right, I'm going to put in parentheses x plus 6. Close it. And we're going to square that. I'm going to hit my division symbol. And my condition was in parentheses, x is less than, so second test, going to choose option 5, less than what? -5. And close. And let's go graph the second piece of this, which is just y is equal to 7. When, or if, in parentheses, this is another and statement. Remember how I've got -5 is less than or equal to x, second math, less than or equal to is option 6, x. Then I want to go back to second math, or the test function, but then scroll to logic and say and, option 1, and x is less than or equal to 2. And again, that's option 6. 2, close my parentheses. There's the constant function with conditions. And then finally, we're going to have absolute value. So I'm going to hit math, number, choose option 1, absolute. And that is 4 minus x. Get clear of my absolute value symbol, hit the division sign, and put in my condition, parentheses, where x is greater than 2. So second test, greater than is option 3. Put in the 2, and hit the parentheses. And hopefully I've entered all that right. And let's see what our graphs look like. Uh-oh, I did something wrong. Where have I got something? Oh. -5. Yeah, get the little, hey, idiot, you did something wrong screen. Now let's see if we got this taken care of. There we go. All right, so I can see the first part of my quadratic coming through here until it gets to where x is equal to x plus 6. So I've shifted 6 units to the left. 1, 2, 3, 4, 5, 6. And where x is 0, when x is less than 5, there's going to be -5, so there's -5. It stops right there. That would be an open dot right there because that was a less than. Then we have the constant function of 7 here in the red. And these would be 2 closed dots because both of those conditions were less than and equal to. And then finally, we got the beginning of the absolute value. 4 minus x. It had a horizontal shift of 4. And this would be an open dot right here at the beginning on the left in behavior of this absolute value and continue on out to infinity. All right, that was a lot of fun.